Let's analyze and solve the longest substring without repeating characters coding problem. We are given a possibly empty string S, and we have to return the length of the longest possible substring in that string that contains no repeating characters. From the view of coding, we have to write a function. We can call it length of the longest substring. The function will have one argument. It is going to be our string S, and the function is supposed to return the length of the longest substring inside the string S that has no repeating characters. We are also given a set of constraints. We are being told that the length of our string can be 0 and it can be up to 50,000 characters. The string S may include English letters, digits, symbols, and spaces. So the key points are that we have to return the length, not the substring itself, and in the substring the characters must be contiguous. So that's the substring, not a subsequence. Any character counts. That means that if we have a double space in the string, space and space, they would count as a repeating character. So any character that repeats count as a repeating character. Let's look at the following example. So we have a string S, which is AB, AB, CDE, and what we are being asked for to return the longest substring with no repeating characters. And in this case, this is going to be the longest substring. So A, B, C, D, E. It has 5 characters. We cannot include any more characters because if we moved to the left, the B would repeat. So in this case, we would have to return 5 as our answer. And that's the problem we have to solve. To solve this problem, we can start from a simple brute force approach. And the idea for the brute force approach is as follows. Given an input string S, we will create all possible substrings of that string. And then for each of those substrings, we will be checking whether they contain a repeating character. If a substring has a repeating character, we will just reject this substring. But if the substring has all unique characters, so there are no repeating characters, we will be tracking what was the longest length of any of those substrings. And once we process all the substrings, we will know what is the answer to our problem. So we have 3 problems in these brute force solutions we have to address. The first one is we need to track the longest substring with no repeating characters we found. For that, we will use a variable. Let's call it maxlen. And each time we find a substring that doesn't have a repeating character, we will compare the length of that substring with our maxlen. And if that length is greater than maxlen, we will update the maxlen. The second problem we have to solve is how to generate all substrings of a given string. So given our example string A, B, A, B, C, D, E, what we can do, we can first start and generate all the substrings that start from the first character. So let's say we have a index called start, and we can point it to the first letter and generate all the substring, and then we move it to the next letter and generate all the substrings starting from B, and we move it to the next letter and generate all the substrings starting from A, and so on until we reach end of the string. So this translates to a simple for loop that starts from the index 0 and goes up to the length of the string. And now to generate all the substrings for a given start position, we will have a second index. Let's call it end. And those 2 indexes define a current substring. So in this case, the current substring is just A. And if we want to generate another substring, we just move end to the next position and our substring becomes AB. And so on. The third substring, we move end to the third position and the substring is ABA. And this continues until we reach the letter E in our case. And once we generate all the substrings from the start position, which points to A, we reset the end we will move the start to the next position, which will be B. We will set end to B and repeat the procedure and generate all the substrings that starts from B. And that's how we can generate all the substring for our input string S. The final problem we have to solve is given a string, let's say our string is ABA, how can we find if that string contains a repeating character? For that we will use set. So we will have a set of characters, and what we will do, we will process our substring. So we will start from letter A, and we will check whether that letter is in the set. It is not, then we will add it to the set and move to the next character. And then we will again check whether B is in our set. It's not, we will add it to our set. And we will move to the final character. And then we will again check whether letter A is in the set. It is in the set. And that way we will know that we found a duplicate character. If we were able to process the entire substring and we never found a matching letter in our set, that would indicate that that substring only contains unique characters. And that's pretty much the entire idea for the brute force solution. The complexity of this solution is of n cubed, and the n cubed comes from two places. To generate all the substrings, we need two nested for loops, and this gives us a O of n squared. Then to check whether a substring is unique, we need another for loop, which gives us another O of n, and those two combined give us O of n cubed. The space complexity is O of 1, and that's because even if we are using an additional memory in our set, that additional memory is constant because there are only, let's say, k different characters possible in our string. Those which were enumerated in our constraints, these were English letters, digits, spaces, symbols. So there is a limited set of such characters. So our set will at the most have a k entries, and O of k, where k is constant, is the same as O of 1. And that's why the space complexity for this solution is O of 1. And that's the entire brute force solution. Our brute force solution works, but the time complexity is pretty bad, is n cubed. And with small improvements, we can change this algorithm to have a time complexity of n squared. And let me show you what we can improve. So let's look at the position at the screen. Our start is pointing to B and n is pointing to B. So the current substring is just a letter B. And for that, in our original algorithm, we would have this substring. We would next go and check whether B has any repeating character. And if it doesn't, so we would update max len. And then we would move to the next character, which would lead to a substring BA. And we would again check that substring BA, whether it has a repeating character. It has not a repeating character, so we would move to the next position and our substring would be BAB. We would check whether this substring has a repeating character. It has a repeating character, so we would not be updating max len. We would next move to next position. We would have a substring BABC. And again, for this substring, we would do a check whether it has a repeating character. It has a repeating character. And we would continue until we reach the end of the string. But what we can observe is the moment that we find a first substring, which was BAB, that has a repeating character. The repeating character is the letter B. All subsequent substrings will also have the same repeating character. So there is no point of generating more substrings once we find the first substring that has a repeating character. And the first optimization is that the moment we find a first substring that has a repeating character, we can exit from that inner loop and move start pointer to the next character and start generating substrings for the next starting position. So that's the one optimization we can do. The second optimization is that if we look at those substrings, the first one is just a letter B, The second one is also letter B, but we added A. So we are appending new letters to the previous substring. So the third one is BA and it has appended B. And next one is BAB with the additional C. And with that observation, what we can do is instead of generating the entire substring and then checking whether it has a unique character, we could check the uniqueness of the characters for each and every character as we are appending them at the end of the substring. So just to make it clear, let me show you how it works, starting from clean slate. So we will use the same input string. And we will also have a maxLen variable to track what was the longest substring we were able to find that had no repeating characters. And we will also use set to check the uniqueness of the characters. And I will just point the few initial steps. The rest of the algorithm should be clear. So let's start from the first position. And we have start that points to the first letter A and end that also points to the first letter A. So our substring is just a letter A. And in this new improved algorithm, what we would do, we would first check whether the letter pointed by end is in our set. So the set is empty, the A is not in the set. What we would do, we would add A to the set. And then since we know that there are no repeating characters, we would compute the length of our current substring. And we would compute it using the formula. So the current len equals end minus start plus 1. In our case, start and end are 0, so 0 minus 0 plus 1 is 1. It is greater than max len, so we would update max len to 1. We would next move end to point to the next letter, which is B. We would check whether B is in the set. It is not, so we would add B to the set. And our substring would become AB. And then since this substring doesn't have a repeating characters, we would check what is the length of this substring. So the end is 1, start is 0, 1 minus 0 is 1, plus 1 is 2. 2 is greater than max len. So we are updating max len. And then we move the end pointer to the next character, which is A. And we first check whether A is in the set. It is in the set. That means we found a repeating character. So we don't really have to generate any more substrings for that starting position A. We would immediately exit from the inner for loop and go back to the outer for loop, which would move the start pointer to the letter B, and the whole cycle would repeat. So with that improvement, our time complexity becomes O of n squared, because we just have two nested for loops. We don't have a third for loop to check uniqueness of a substring. And the space complexity remains the same. It's still of 1, because our set will have at most k characters, where k is the number of all possible different characters that can be in the string. So we would have O of k, and since k is constant, this is the same as O of 1. And that's how we can improve the time complexity of our brute force approach from n cubed to n squared. There is a solution which gives us a linear time for this problem, and the solution uses a technique called a sliding window. So before we talk about this specific problem, let me give you a quick introduction to the sliding window technique. So this technique is useful when we have a input data that is sort of like a vector or an array or a string, and we maintain two indexes, left and right. And the way that algorithm works is that for each position of those two indexes, we check whether a certain constraint is maintained. In our case, for our string problem, the constraint is whether the substring between the left and the right, inclusive, contains unique characters. If the constraint is maintained, then we move the right pointer. And again, we check whether the constraint is maintained. And if it is maintained, we often update some result value. In our case, would be max len. And at some point, when we move far enough, it often happens that the constraint is no longer maintained. Like, for example, we just found a repeating character, in which case we move the left pointer to the position that is far enough so the constraint is now maintained again. And we move through the entire array, and the moment we reach the end with our right pointer, the algorithm is done. So we found whatever the answer we were looking for. And with that in mind, let's show how it works in the case of our specific problem. So let's use the same input string. We will again maintain a max len variable. We initialize to 0, and this is going to track what is the longest substring we were able to find that has no repeating characters. We will also use a map. A map will be from char to int. We can call it last seen, or maybe last seen index. And the idea is that as we go through that string and we find all the different characters, we will insert those characters, and the value in the map for a specific character will be the position or index in our string when we last seen that specific character. So let's show how this would work in our example. We will have the left pointer, left index, and right index. And the first thing we do, we check whether the A is in our map. It is not in our map, so we will add A to the map with the index 0. And then we will compute the current length, and it will be right minus left plus 1. In our case, right and left are zeros, so it would be 0 minus 0 plus 1 is 1. It is greater than the max len, so we would update the max len to 1. And then we would move to the next character. So the right points to B. We again repeat the steps. We check whether the B is in our map. It is not, so we will add B with the index 1. And we will compute the length. So 1 minus 0 is 1, plus 1 is 2, greater than max len. We change max len to 2. We move right to point to A. And now we check whether A is in the map. It is in the map. So our constraint, which is that there should not be repeating characters in the substring defined between left and right, is now false. We have a repeating character. So before we move forward, we have to update left pointer so the constraint is maintained again. And to do that, we have to check what was the last position of A, of our current character. It's in the map, it was 0. And we have to skip over that position. So in this case, we have to move to the position which is 1 past the last A, which is 0 plus 1 is 1. So left would now point to B, index 1. And now our substring left to right is BA. The constraint that there should not be repeating characters is maintained. So we have to update our A because last seen A is now 2. Let me write down those indexes. So it's 0, 1, 2, 3, 4, 6. And we again repeat the steps. So we would compute the length. Right is 2, left is 1, 2 minus 1 is 1, plus 1 is 2. We don't have to update max len because max len is already 2. We would move to B. We check whether the B is in the map. Yes, it is. So the constraint is no longer maintained. We have again repeating character, in which case we have to move left to the position 1 past last seen B, which is 1 plus 1. Last seen B was at the position 1. So our left pointer would now move and point to the index 2. So we skipped over the B that was at the position 1, at index 1. And now our string from left to right is AB. We again compute the current length, and 3 minus 2 is 1, plus 1 is 2. So we don't have to update the max len. We move right. We have to update the last seen B. So this should be 3. And then we would move the right to point to C. C is not in the map, so we would insert C into our map with the value 4, because that's the index of C. And we would compute the current length. So right minus left, 4 minus 2 is 2, plus 1 is 3. We have a 3 that's greater than 2. We update max len, and we move right to the next position, D. D is not in the map. We add D to the map with the value 5. And then we compute the current length. 5 minus 2 is 3, plus 1 is 4. We have to update max length. And we moved finally to the last character in our string. So the right is now pointing at the last character. E is not in the map. We add E with the value 6. That's the index. And then we again compute the current length. 6 minus 2 is 4, plus 1 is 5. 5 is greater than 4, so we have to update max len. And as I said at the beginning, the moment we reach the end of data, the algorithm ends, and the answer is stored in our max len variable, so we would just return 5. And that's the idea how we can use sliding window for this problem. The time complexity for this algorithm is O of n, because we have to just scan through the string one time, and the space complexity remains of 1. We use map, but that map will only have up to O of k size, and k is a constant. K is the number of different characters that can appear in our string. So that's the optimal solution for this problem, and that's how we can solve it using sliding window. Let's write code for our solutions, starting from the worst brute force solution. So we will start from computing the size of the string and storing it in the const. Next, we will define our max len variable. With that, we are ready to process the strings. So we will have 2 nested for loops. So the first for loop is for the start pointer. We start from 0 and we will go until the end of the string. And the next for loop will be for our end pointer. And now we have our substring from start to end, and we have to check whether it contains all unique characters. For that, we are going to use set. So we defined a set of characters. We are going to call it scene. And we will also introduce a Boolean variable called isUnique. And now with that, we can process all characters in our substring from start to end and use the set to find whether any of those characters repeat. So in the above code, what we are doing, we are processing each character in the substring using the index k. So we start from the index start and we go up to the index end. And then for each character, we check whether our set contains that character. If it does, then we know that it is not unique and we break. Otherwise, we insert the character to the set. And after that, we have to make sure that the isUnique flag is true. And only if it is, we will update the max len. So what we are doing here, we are updating the max len using the standard max algorithm, and it will take the maximum of either max len or the length of the current substring, which we compute using the formula end minus start plus 1. And after that, our algorithm is finished. What we have to do is we just need to return the max len. Let's see if we can build this code. The code builds okay. So let's see if it passes the test. And we see that the tests are stuck on the last test because it's a very inefficient algorithm. And if we take a look on our tests, we have 50,000 characters. So this is going to be a bad experience. And the algorithm, which has a time complexity of n cubed, is not good enough for such a long data. So I'm going to break it. So we coded the brute force algorithm. It works for short strings, but it doesn't work well for long strings. Let's write code for our second version of brute force algorithm, the one that runs in O of n squared time. We will start from storing the size of the string in the constant. Let's define the maxlen variable. And now let's write two for loops, one for the start of the substring and another one nested for loop for the end of the substring. And the improvement we made in this version of brute force algorithm was that as we move our end pointer, we are also checking whether the character pointed by the end was already seen. So for that, we will define a set. And now since we have a set, we can write a second for loop. And in the second for loop, what we have to do is we have to check whether the s of end has already been seen. And if it has, we can simply break out of this for loop. We are breaking because we found a duplicate character, so there is no point of continuing moving the end forward. We will have to move the start. But if the character is not in the set, we have to insert it to the set. And then we have to update the maxlen. To update maxlen, we use standard max algorithm, which picks the maximum value out of either maxlen or the length of the current substring, which is the end minus start plus 1. And with that, our algorithm is done. So the last remaining part is just to return maxlen. Let's see if we can build this code. The code builds okay. Let's see if it passes tests. All tests have passed. So we have successfully coded our improved brute force algorithm. Let's write code for our optimal solution. We will start from storing the size of s in a constant. And this solution uses map, so let's define a map. So our map has a character as a key and int is a value. The int will be the last index we have seen the character at. Let's also define the maxlen variable. And let's define our left pointer. We initialize it with 0, so the left pointer starts at the beginning of the string. Now we will write a for loop for the right pointer and go through the entire string and following our logic. Since we are going to refer to the current character pointed by the right many times, let's store this character. And now we have to check whether we've seen this character inside our map. And if we've seen that character, we have to make sure that it is inside our window, because we could have moved the left pointer and the character which is now repeating could be outside of the left to right window. So we have to do one extra check. So if this character is inside our window, that means it will be the repeating character inside our substring. Because of that, we have to move the left one position further than the last seen character. With that, we have taken care of shifting the left if it so happens that we found a repeating character. So we have to now update the last seen index for the current character. And it's basically setting the last seen index of current character to the current right position, which is our current index within the for loop. And with that, we can just update the maxlen. And to update the maxlen, we use standard max algorithm, which will pick the maximum of the two. The first value is maxlen, the current maxlen, and the second value is the length of the current substring. And that's the entire algorithm. What is left to do is just to return max left. Let's see if we can build this code. we can build it. So let's try to run the tests. All the tests have passed. So we have successfully coded the optimal algorithm for this problem. Let's make sure our code passes all LeetCode tests. Let's start from the worst brute force solution. We should expect this solution to get TLE, time limit exceeded. Let's see if it works. It works. Let's now submit it. And as expected, we got time limit exceeded because this solution is incredibly inefficient. Let's now try the optimized brute force solution. Let's see if this solution works. It works. Let's try submit. We were able to submit, but the performance is very bad. So let's now try our optimized solution. Let's see if this solution works. It works. Let's see what happens if we submit it. And we were able to submit and we got much better performance. So all our solutions are properly coded, but the worst brute force one is giving us time limit exceeded at LeetCode as expected. This is the end of our solution. The source code is available in the GitHub repo shown on the screen.